Good morning, grade 10. Again, let's continue with the discussion. This is a continuation of the Earth's natural processes. We are now in crystallization of magma. Okay. Can you hear us, Matthew? Matt?
Yes, teacher.
Matt, can you hear us?
Yes, teacher.
Okay. Crystallization of magma. Okay. What do you think is a rock, or what do you think? What kind of rock would a magma or a lava will become when it hardens? What kind of rock? What kind of rock? Obsidian? Obsidian? Are you sure? Yes. It will become igneous rock. Okay. Let's take a look at the crystallization of magma. Okay. Magma, meaning to say that it is filled inside your chamber. Okay. It is actually cooled inside. Right? The magmas formed under the earth are less dense. Okay, when you say less dense than the surrounding solid rocks. If it is less dense, we need to say that it is buoyant enough, okay, and can move upwards. Another reason for their movement is the pressure exerted within the surrounding rock, right, which squeezes magma. The rising magma oozes along grain boundaries and move up along cracks. As it rises, it enters cooler environment, begins to cool. So it will actually cool before reaching the Earth's surface. So let's take a look at this one. Crystallization occurs when magmas cool and mineral grains start to form. Okay? Some magmas move all the way to the surface, but some solidify underground, not even reaching, not even reaching the Earth's surface. The solidification of magma is actually forms a or an igneous rock. It forms an igneous rock. What kind of igneous rock then? It is actually the gray. When a magma solidifies, not even reaching the Earth's surface, it actually forms an igneous rock. Okay? But this is a different thing. Why? Why? Because it solidifies, okay, inside the chamber. Okay? It doesn't actually reach the Earth's surface. Okay? The common minerals of igneous rocks are quartz, orthoclase, plagioclase, muscovites, biotite, amphiboyle, pyroxene, and olivine. Orthoclase and plagioclase are cold feldspar. Okay, these feldspar are actually the components of some of the igneous rock. Okay, where did we get all these components? Okay, it is because again there is the building of pressure inside, and we collected all of this in the process. Okay, while biotite and muscovite are called mica or mica. Okay, again, orthoclase and plagioclase are actually called stars. So if the question in your exam is asking what are the composition of a feldspar, it is actually orthoclase and plagioclase. But if the person there is actually asking about the composition of mica or mica, we have muscovite and type. Take down notes. Most magma never reaches the surface. Four, they put it underground, form bodies called igneous intrusions. So these are igneous intrusions. Right? In some cases, it forms a wall-like sheet called dike, okay, or it forms a tabular layer called sill, dikes and sill. If it is actually in a wall-like sheet, it is dike. Okay. If it is in tabular layer, in tabs form, okay, it is called sill, in between pre-existing rock layers. Say no, no. Okay, let's move forward. Please take down for terminologies because again, this is how we study that. They were like different sciences a lot. We have to be familiar, right? Okay. Again, lesson one is just an introductory lesson. This is the actual lesson. Okay. We tend to look at it in general first, and we will move to the specifics. These are not specific. It can also form a blob-like configuration called pluton, and forms many configurations. The amalgamation of many plutons is called batholith. Okay? The formation of different plutons is called a batholith. Okay? It occupies very large area in the order of tens to hundreds of square kilometers. Okay, batholiths. You can actually download the PPT again. Please download it so that you can have your notes with you. Okay, because some of the terminologies there are not actually on the I will not support for a single author or book. I have different sources. That is why. Okay. Let's move now to volcano. Okay. We do know already that when a magma solidifies, okay, inside the chamber without reaching the Earth's surface, it is called the igneous intrusions. These rocks are actually what? Composed of different minerals, okay, solidified minerals from, again, created from pressure, okay, beneath the Earth's surface. Let's move now to volcanoes. Okay, volcanoes are visible manifestation of process of rock formation. It is a vent that serves as the conduit, okay, of lava or molten rocks that reaches the Earth's surface. The funnel-shaped depression where materials ejected are called crater. So you can actually have a volcano with this crater. So how can we identify volcano? Number one, it should have a crater. Okay. Sure. How about the volcanic beds? Do they have craters? Yes, they have craters also. The event when the lava is spewed out of the volcano is called eruption or volcanic eruption. Okay. There are two types of eruptions. We have effusive eruption and explosive eruption. Let's take a look at effusive eruption. It is dominated by the flow of lava and formation of fountains and lakes. That's the effusive eruption. So just like a lava flow, it's an effusive eruption. We need to say that it is a silent eruption. It erupts, but it is actually moving slowly. Okay. How about explosive eruption. The term itself will give you an idea. It ejects ash and larger fragments of earth-fusing materials, forming ash clouds that eventually collapse and cover slopes in volcano. This can actually cause lahar. Okay, what is lahar again? Lahar is actually in the lower grade. Okay, lahar is a mixture of lahar. This can actually cause lahar. Lahar is a mixture of ash and water. Ash and water. Okay, during a volcanic eruption. Right? The composition of lava controls the type of eruption. Okay? Lavas with low silica content are less viscous and are able to flow more rapidly, generating diffuse eruption. If it flows easily, it actually causes diffuse eruption. But, okay, explosive eruption is associated with lavas having high silica content and are more viscous. The more viscous it is, the more violent it is. Okay? Explosive eruptions are always associated with violent eruption. Okay, please take down notes. The dissolved gases in magma develop a very high pressure as it rises toward the surface. Sudden pressure is released at or very near surface or the surface, triggering fragmentation and blasting. This is under, again, violent eruption or what? Your explosive eruption. Just like this. So this is a typical example of effusive eruption. Okay, this is a typical eruption of explosive eruption. Okay, as you can see, the difference there is that the viscosity of the lava, number one. Number two, the behavior of the eruption. Okay, and of course, the composition of your lava. As we had observed, if it has less silica content, okay, if it has less silica content, this is less viscous, meaning it means to say that it can actually flow easily. That's under effusive eruption. But if it has a more silica content, okay, it is more viscous. In vernacular, it's more lapot. Tendency is it can actually what? Perform a violent eruption or a, are you still with me? Are we good? A violent eruption or explosive eruption. There are three different kinds of volcanoes according to its shape. So we can actually identify volcanoes according to their shapes. Okay, let's have first the shield volcano. Did you tackle this one in your lower grade? Yeah. Okay. Shield volcano forms a very broad dome with a gentle slope that covers a very wide area. They are mostly made of alternating layers of basaltic lava and cinder accumulation. Basalts. Basaltic lava and cinder accumulation, that's under shield volcano. It forms like a shield, okay, with different layers. It covers actually a very wide area and made up of alternating layers of basalts or basaltic lava and cinder accumulations to form a cinder cone. Cinders are granular material formed by lava fountains. Okay, the volcanoes in Hawaii are shield volcanoes. Let's move now to stratovolcanoes or the composite volcanoes. Okay, these are composed of alternating layers of lava and pyroclastic materials. If there are some pyroclastic materials, you know already what eruption occurred in these volcanoes. Okay, they are generally composed of intermediate felsic rocks and tend to build large or high volcanic edifices. Examples may include Mount Mayon in Albay and Mount Pinatubo. Strato. Edifices or edifice are the surface of these volcanoes. Sure, how about Mount Pinatubo? Is Mount Pinatubo a composite volcano? It is a composite volcano. Okay? It is a composite volcano. Okay? You can actually observe that with their edifices in their surface. Okay? The third type is the cinder cone, okay, which consists a small cone formed by sputtering of lava. Okay? It is composed of cinder with mafic composition. Okay? Binintaang malaki, located within Taal Volcano and Smith Volcano in Babuyan Island are examples of cinder cone. So they look like um actually cones. Yes, I have seen one. And the eruption there, because this is a cinder type, is again silent eruption or the silent eruption. Okay, the flow of the lava there are very slow that it forms a cinder. Question so far? So these are the differences based on their form. Again, composite volcanoes. Okay, you can actually observe that it has what? The form, look at the form of composite volcano, just like your Mayun. It has a, look at the tip of the volcano. What can you observe? Okay. With these three examples, what have you observed? Huh? Composite is higher. What else? What are the other observations there? How can you differentiate them? How can you differentiate them? Huh? You're all okay. How can you differentiate them? Yes, correct. There is the lava. Look at the lava there. Okay. It is based on the movement of lava that it actually resembles that specific form. Okay. Do you have any questions so far? Questions so far? Okay. Larger non-streamed chunks of lava or pre-existing rocks are called blocks. Okay. The aggregate pyroclastic debris that flows on the slope of the volcano is called pyroclastic flow deposit. Okay. The debris that flows outside the volcano or the slope of the volcano, it is actually called as pyroclastic flow deposits. There are a lot of terminologies there. Okay, that's what I am telling you all throughout that this is a continuation of your previous lesson in the lower grade. Okay? A pyroclastic deposit that is dormantly composed of pumice is called the ignimbrite. Okay? Before I have samples of these rocks in my previous school, but again, I don't know where I actually put it after Odette. But I have rock samples with regards to this. I collected some. When the pyroclastic debris mixed with water, it forms a muddy-like slurry called lahar. This is now lahar, one I'm telling you. It is a mixture of, again, mixture of pyroclastic debris or ash. These are ash. Okay? Ash and water. It forms a muddy-like slurry called lahar. And this is the problem of the people living nearby volcanoes because they might experience this. It's been covered in our earthquake. Do you have any question with volcano? Okay. Questions with volcano? How about earthquakes? Sure, if there is an earthquake or there is a volcanic eruption, there's always an earthquake. Question again. Why do earthquake is always associated with volcanic eruption and tectonic movements? Again, why do earthquake is always associated with volcanic eruption and plate? Let's have roundings. The question is, why do earthquake always associated with volcanic eruption and plate tectonic? Associated, meaning if there is a movement in the plate, there's always an earthquake. There is a volcanic eruption, there's always an earthquake. Why do you think? How do they connect? Because of the high energy potential of the right? You have a point? Yes, okay. Correct. Any other idea? Why is it always associated with volcanic with earthquake? Because again, it is what? It is the way nature moves. Okay? These seismic activities are indication that Earth is continually forming itself or healing itself. This is nature's way of healing itself. And it is always associated, or earthquake is always associated with volcanic eruption and plate tectonics simply because, again, it can cause trembling of the lithosphere or your grass. Right? That's what it is. Earthquake. Okay, an earthquake is a vibration on the surface of the earth resulting in the sudden release of energy. Okay, it could be a small shaking that could sway hanging objects or very large movement that could destroy buildings and cause catastrophic damage, just like in Japan. Okay, Japan always experienced this simply because, again, they are very near to Pacific Belt Ring of Fire. We are also in the Pacific Belt Ring of Fire, but Japan is very near. The tendency is there are a lot of tectonic movements there, even volcanic eruptions. So they usually experience this. So they already adapted to this. Okay, that's why their buildings is they constructed a different building. Okay, that can sustain or can surpass a possible um earthquake. Okay, did you know that our first bridge and the second bridge in Mandaue and Lapu-Lapu are constructed based on Japan's technology? They already tested that one with possible earthquakes. They already tested that one. They let it tremble before turning it over to the government. Okay, that's the Japan technology. Right? The breaking of rocks beneath the surface or the Earth's surface as the result of tectonic forces produces earthquake, as always. Okay, we already know this. It is analogous to the breaking of stick. When you hold the stick on the opposite end and bend it, it applies stress or directed pressure, storing energy in it. And when you actually bend a stick, so when you bend a stick, you're creating what? A stress in the middle of the stick. So just like it is just um the same or analogous to the bending of rocks beneath the earth, or in the earth's surface rather. When the force is suddenly removed, the stick will bounce back to its original form, okay, releasing the stored energy. After continuously bending, the stick will suddenly break and release energy in the form of vibrations. It will vibrate, okay, and sound it returns to its original unbent form, but it is already shortened and divided into two. Okay, this concept is called the elastic rebound theory. Okay, the concept of the elastic rebound theory is that when there is a bend or when the bending of the Earth's surface occur, the tendency is it created or it will create stress in the middle of the bended area. But after which, okay, after bending, okay, if it breaks, it will return to its shape, okay, but divided into two already because you already break or it is already broken into two, okay, and return to its original shape. That's the elastic rebound. Are we good? Are we still good? Yes, yes, please. Okay, you still have time. By the way, class, okay, Ravi, would you assign somebody the monitor? Are you familiar with monitor? Monitor. So the monitor is assigned to check on time and remind your teachers the time. I'll be putting also some clocks in our classroom, okay? But the table clock, I'll put it over. Okay. So monitor, if you already assigned monitor, Ravi, you remind the teachers about their time. Okay. Let's continue. Do you have any questions so far? You sure? Earthquakes in rocks cause structure to form. Earthquakes could also occur when there are existing fractures or faults that undergo renewed episode or episodic or episodes of sliding. Okay, a fault is a fracture on which one body of rock slide past one another. Okay, faulting happens when the stress acting on the fault exceeds the frictional force on both sides of the fault. Okay, we already know what is faulting. We already know what are the different types of faults or faulting. Okay, majority of Earth's or earthquakes in the planet are due to the movement of pre-existing faults or the Earth plate tectonics. Other causes of earthquakes include movement of magma underneath a volcano, explosion of a volcano, large landslide, meteorite impact, okay, and underground nuclear bomb tests, okay, or man-made. Okay, again, another fault, as you can see, still the same. The fault there will always be the fault that we had discussed in previous lesson, lower and lower grade. The place where rock ruptures and split is the focus or epicenter. We know already this. Energy radiates from the focus outward to the surface. The point on the surface directly above the focus is called the epicenter. You know already this. The location of the earthquake is defined by its geographic location or geographical location, which is the latitude and the longitude. This is your geographical location, specific location, by but also by the depth of the focus. Okay. We usually what? Check on the location of this earthquake or the epicenter by its geographical location. Where does this earthquake actually located? The actual location of this earthquake. The energy released from the hypocenter for an earthquake travel as seismic waves. You know already this. There are different types of seismic waves, distinguished on how they move. Waves that travel within the interior of the earth are called body waves. Simple. Okay. So what are these? What are the different types of waves? Let's have the P waves or primary waves. We already discussed this one in your lower grade, correct? Okay. P waves are bodies or body waves in which particle material move back and forth, back and forth. So the movement is back and forth. Okay. Parallel to the direction of the wave motion, so back and forth. That's the movement. It is also a compressional wave. It creates compressions. Okay. Another type of wave is called the secondary wave or S waves. Okay. These are body waves where particles materials move back and forth perpendicular to the direction of the wave. Okay. They're also referred to as shear waves because it can what? It can tear and shear. Okay, tear and shear the crust or your lithosphere. Okay, another differences with regards to P waves. P waves travel in both solid and liquid, while secondary wave can only travel to solids. Okay, it cannot travel in liquid. Perpendicular or the same level or with other terms perpendicular along to the direction of the wave. Any other question? Any other question? So the movement of P waves, okay, is parallel. So in parallel direction. The movement of secondary wave, since it is perpendicular to the direction of the wave, along with the wave, how do a wave move? Along with the wave. The wave is moving, correct? So the movement of the secondary wave is perpendicular to the movement of the wave motion. So the result is up and down. That's the movement of the secondary. That's why it is called the shear waves because it can tear and shear your lithosphere. Okay. Waves travel along the Earth's surface are called surface waves. We already know that. Rayleigh waves, okay, is take note of this. Rayleigh waves are surface waves that cause the ground to ripple up and ripple down. Just like when you throw a stone in a pond, it actually forms a ripple effect. That is the Rayleigh waves. Okay. The next wave that we have is the log waves. Log waves. Log waves are surface waves that cause ground to move back and forth in a snake-like movement. Back and forth. So the movement is back and forth, but in a snake-like movement. So let's take a look at this one. Okay, the different examples. Okay. Remember your P wave. This is your P wave. Okay? It is actually moving back and forth. Okay. Your S wave is actually moving in the same or perpendicular to the wave. Okay, because wave is moving in this direction. So the movement of the secondary wave will always be in this direction. Right? So it is up and down. Okay. While love waves, okay, is actually moving with the same with the P waves, but you look at the movement. It is in a snake form. So instead of having the S wave there, instead of having that one, okay, we have still the same, parallel, but in a snake movement form. So this is now the movement of the love waves. While the Rayleigh waves, as you can see, okay, it is actually forming a ripple effect. Okay, a ripple effect of what? A ripple effect in your lithosphere. Sure, what are the differences? Okay, since this is a ripple effect, it is a combination of what? secondary wave and G waves. It's a combination. That's why it is actually a ripple effect. It is in a ripple effect. Have you seen the differences? Huh? Are we still good? Oh my God, 100 slides. Okay, let's continue by next meeting. But this will come out in your major exam, still the same? Oh.
Will come out and then
All of it. Course. Is that we have actually seen business, the advisory. Some of them are all so